Okay, cool guys. So we're on question 9 of the grade 12 June 2025 math paper 2 paper, and this is the last question of the paper. This is a similarity and prop theorem question. Okay, so 9.1 in the diagram below, PQ equals QR equals RS, and VR is parallel to TS. So 9.1.1, they set up to help us with 9.1.2, determine the value of TV over VP. So what we can do, this PQ is X, this QR is X, and this RS is X, which means that this portion here represents 1X, and this portion here represents 2X over there, which means we can just go one move. We can write TV as X over VP as 2X over there, and therefore cancelling out the X's, we have 1 over 2 is the value of TV over VP. Okay, and we just earned 1 mark over here for determining the value of TV over VP, and then we just need 1 mark for our reason saying prop theorem. So then 9.1.2, it says determine the value of the area of triangle PQV. Okay, we got PQV over there over the area of triangle PST over here. So this is a 5 mark question, and what we need to do is use our area of a triangle formula, but not the half base times perpendicular height. We need to use our trig and triangles area formula, where we have half AB sine C. This is very common to use this formula in a similarity section. Okay, so I'm going to go ahead and set up the area of triangle PQV so long. So we're going to take half VP over here. The other side is going to be PQ over there. So we're going to go half PV times PQ multiplied by sine of the angle in between these two sides, which means it is angle P over here. So we're going to go sine P. The reason we want to work with sine P specifically is that it is a common angle in this triangle VPQ and also in triangle TPS, which means that it is going to cancel out quite nicely for us. So if we then go ahead and set up the area of triangle PST, we have half as well, because that is our formula. And then what we're working with in PST, PT over here times by PS over there. Cool. And then once again, it is this whole side here and this whole side here, which means we're working with sine of P over here as well. So that means we can go ahead and cancel some things along. There's no reason for this. This is just the setup so that we don't have to write any words here explaining why we've done this. So we can cancel our half and our half because they're exactly the same. So we can cancel them and our sine P as well. So that means we have PV over PT multiplied by PQ over PS. The reason I split them up was because these sides over here, PV over PT is just one side of our triangle, and PQ over here is this guy over PS over there, that is the other side of our triangle, which means at this stage to use 9.1.1's information as far as how we set up our triangle in terms of X, we can then go ahead and plug in the values for PV and PT, because PV equals 2 or 2x, and then PT over here, PT equals 3 or 3x if we want to keep the x's in. Either way, they're going to cancel each other out, the x's. PQ here is 1 or 1x, and then PS over here is 3. So then at this stage, there were no reasons for these guys specifically. We can just times top and top and bottom, and then we'll have a final answer of 2 over 9 there, and that'll be the value of this area of triangle PQV over the area of triangle PST, and that will earn us 5 marks. And then question 9.2, in the diagram below, B, C, and D are points on the circle, and ADC is a straight line. AB is a tangent to the circle at B. Tangent, always important. Prove giving reasons that triangle CBA is similar, so the angles are exactly the same, to triangle BDA. So this is a 4 mark question. So we have triangle CBA over there and proving that it is similar to triangle BDA over here. So I'm just going to rewrite what they've given us. So in triangle CBA and triangle BDA. So these are the 2 different triangles that we're working in. Okay, so now that we know which 2 triangles we're working in, we have to prove the angles that are exactly the same. So they've set things up in a very specific order to help us, meaning that angle C over here is going to equal angle B here, or we need to find a way or a reason as to why that is the case. Same thing here for B and for D, cool. And then A here is the same as A over there, which means the easiest way to start is when they have exactly the same letter. Because if we look in triangle CBA over here and BDA over here, this A is a common angle in both of these triangles. So we can just write angle A equals angle A common angle. So we've just proven that for both of these triangles, which means we can then look at another pair that is corresponding. So let's start with C here and see if that works out for us. So C here and B over here. So angle C and triangle CBA over here. Okay, so we're talking about this angle over here. And then we need to prove that it is exactly the same as angle B in triangle BDA. So we have to prove that this angle B1 equals that angle C. And that is very doable, considering this is a tangent to a triangle in a circle, meaning that B1 equals C because of tan chord theorem. At this stage, we've just proven that two of the angles are exactly the same, which means that this angle here, this B and this D, are exactly the same as well because of interior angles of a triangle. So we can just go ahead and write that. We can say that angle B1 plus B2 in triangle CBA over there equals angle D over here in triangle BDA equals angle D1 because of interior angles of a triangle. And therefore triangle CBA is similar to triangle BDA because of angle, angle, angle. And last question now for this section and this whole paper, 9.2.2, it says AD times DC equals AB squared minus AD squared. So considering we had just proven that this triangle is similar to this triangle, we now have to use that information to help us rearrange something in this format as far as manipulating our similarity. So the most common way at this stage is to rewrite the triangles that you've just proven were similar, so we can then see which sides are in proportion, because we had proven that these triangles were similar through the angles being the same, and the other criteria of similarity is that the sides are in proportion, and that is what we're dealing with over here. So we have triangle CBA and BDA. That means CB over here over BD over here are in proportion. Once again, the arrangement of the letters is very important, just like the arrangement of the angles was very important. So our CB over BD is in proportion. That also means our BA over our DA is in proportion. And then last move, CA over BA is also in proportion. So we just write triangle CBA is similar to triangle BDA as our reason to show us that these sides are in proportion. We then need to go ahead and see which of these sides in proportion, which of these pairs we have to use to set up this equation, because we only need to use two of them. So we have a BA or an AB here, so this guy is probably important. We also have an AD and a DC. Okay, so we know that we're working with this BA over DA because we have the BA over here, but the fact that it is squared means we have to look for one of these other guys that also has a BA. There's also a BA in this one over here, which means we are just working with these two guys as far as our equation, and then we can take it from there, ignoring this portion here. So if we rewrite this over here, we have BA over DA equals CA over BA. In order to get an AB or a BA squared, we're going to have to take this guy up. This is the most common move here, is to take both of the denominators up, considering we do not have a denominator here. So if we multiply the BA up top there, it means we have BA squared. And then if we multiply this DA up there, it means we have CA times by DA. At this stage, we have this AB squared over here. That's great for us, this BA squared. We also need an AD squared and a minus, and things are only multiplying here. Here's a DA, so that's an AD, that's great. Then this guy is a DC, but the CA is not in our final answer, which means we have to do something with CA. So we're going to reference the diagram to see how we can change CA over here into DC by some stretch. So we have CA, this whole thing over here, and we need a DC. A DC is living over here. That's pretty good for us, considering that AC, the CA, equals AD plus DC. That means we can just expand it. We can remove our CA and substitute the AD and the DC. So AD plus DC equals CA. So AD plus DC equals AC, or CA. So we have just removed the CA and replaced it with these two portions over here. Okay, and we are still multiplying by dA over there. So this is looking good for us because now that we have substituted this in, we can multiply each thing in. So dA times AD, or dA, doesn't matter which order the letters are in. AD times AD becomes AD squared. That's great for us because we have an AD squared there. And then AD times DC over here, we have plus AD times DC. We just foiled this guy to both. So AD times AD is AD squared. AD times DC is plus AD times DC. And this still equals BA squared. And then at this stage, we can just go ahead and say BA squared minus AD squared. That is what we have here. AB squared minus AD squared. We can just rearrange the order of our BA squared, saying that it is AB squared. So AB squared minus AD squared equals AD times DC. And that is what we have here, AD times DC. And that is our final answer. There are no other reasons here. This was all just working out and using the fact that these triangles were similar, using these sides in proportion, and did the correct substitution in order to set up this final answer in terms of the setup that they asked for. Great. That is the last question of this section. 4 marks earned, 15 marks for this whole section, and that is the entire paper. Great job, guys. Let me know if there are any questions in the comments below, and then I will see you in the next video.